For this video, we will be talking about section 4.2, which is rate of change and slope. To start, we have some vocabulary here. So we have the rate of change is how a quantity is changing with respect to a change in another quantity. The rate of change can also be written as change in y over change in x. So you'll notice y is on top, x is on the bottom. And then similarly for slope here, we have the slope of a line is the rate of change in the y coordinate or rise for the corresponding change in the x coordinate or run for points on the line. So right here, hopefully when you see rise over run, that is familiar to you. We have our slope formula here. M equals, remember M represents the slope, y2 minus y1 over x2 minus x1. You can also say that M equals rise over run. It's the exact same thing. And then the other thing I want you to take note of is notice for rate of change and for slope, y is always on top and x is always on the bottom. So rate of change and slope are actually very similar to each other. You'll notice with rate of change, we more label our answers and things like that, whereas slope would just be two numbers, relatively speaking. So looking at numbers 1 and 2 here, we have find the rate of change. Again, that would be change in y over change in x. So I'm going to look at these first two ordered pairs right here. So looking at my y values, I'm going to put ROC for rate of change. And from 12 to 24, that was an increase of 12. So then I know that I have 12 on top. And then I know that it increased from 2 to 4 by 2. So then that would be 12 over 2. Now, we do have to simplify this. So if I divided both top and bottom by 2, that would give me 6 over 1. Now, with the rate of change, we are going to label our answers here. So this would be 6 pancakes because that's what y is. If I can spell pancakes, that would be nice. There we go. Pancakes, and then over 1 cup for x. So that would be our rate of change here. Looking at number 2, again, our rate of change is always the increase or decrease in y first. Change in y, so this increased by 4.15. So then I would have 4.15 on top over my change in x. And again, I'm just looking at these first two ordered pairs because this is just asking us to find the rate of change. So we can assume it is linear. So then we would say that this is over 1.25 because that's the increase from 4.75 to 6. Now, since both of these are decimals, I'm actually going to go ahead and just simplify this. Technically, I'm dividing 4.15 by 1.25, so that would give me 3.32 over 1, technically. So then again, if I labeled this, that would be $3.32 for each gallon. And then looking at 3 for part A and B, we are finding the rate of change for 2000 to 2005, and then we're also going to find the rate of change for 2010 to 2015. We're talking about a student council budget and how it either increases or decreases. So you'll notice right here that this entire graph is not linear. The entire thing is not a straight line. However, little sections of it are straight lines. So we can talk about the rate of change for each section, just not the entire graph as a whole. So part A says find the rate of change for 2000 to 2005. That would be this dot right here and this dot right here. So the first thing I'm going to do is list the ordered pairs. So the first one would be 2000, comma, 1350. That's the number that goes with the year 2000. Then we have 2005. And that number pairs with 1675 for the y value. Then you'll notice that this kind of looks like our table that we had earlier. So again, our rate of change would be change in y, and this has an increase of 325 from the first number to the second number. And then that would be 325 on top because it's always change in y over change in x. And then over, this has an increase of 5, so then over 5. Again, we're going to simplify this, so that would be 65 over 1, and then that would be our rate of change, but then you'll notice that it says we have to actually describe the meaning in the context of the situation. So I would say that 65 is the y value, and that would be dollars, and then 1 is years, because that's the x value, so then that means, we can write this means, the budget increases, since it's positive, $65 per year. So on part B, we are doing the exact same idea. However, we're looking at 2010 to 2015. So then again, I'm going to list my ordered pairs. So 2010, comma, 1550, and then 2015, comma, 1325. So then again, find the rate of change first. Rate of change is always change in Y. So we have ROC here for rate of change. This is a decrease, so negative 225. And this over here, 2010 to 2015 would be adding 5. So then I would have negative 225 over 5, which simplifies to negative 45 over 1. That would be my rate of change. And then similarly to what we said up above, this means the budget decreases $45 per year. And again, that decreases takes care of the negative that's there with the 45. Okay, let's go ahead and go over to the back side. Okay, so on the back, we have constant rate of change, determine whether the function is linear. So first things first, we need to make sure that this is linear. And in order to do that, we need to make sure the x is increasing by the same number over and over again. And then the y values are also increasing by the same number over and over again. So if I look at the x column here, 11 to 8 decreased by 3. 8 to 5 decreased by 3. 5 to 2 also decreased by 3. And then 2 to negative 1 decreased by 3. So far, the x values are, they have a constant rate of change. So then if I go to the y values, negative 5 to negative 3 would be adding 2. Negative 3 to negative 1 would also be adding 2. Negative 1 to 1, adding 2. And 1 to 3, adding 2. Remember from the last chapter, you do have to check every single value to make sure it is linear. Don't assume because the first two go by 2s that the rest of them do. You should always double check that that's true. So first things first, this is linear. So I'm going to go ahead and write that because that was the first part of our directions. Now it says if it is linear, state the rate of change. So then we're going to put ROC. And again, rate of change is always change in Y over change in X. The Y values are changing by a positive 2 every time over the X values are changing by a negative 3 every time. So then that would be our answer. It's linear and the rate of change is 2 over negative 3. Notice that can't be simplified at all. So that is our final answer. Okay, looking at number 5, notice this table is going horizontally now. So make sure you're careful of that. But 22 to 29 would be an increase of 7. 29 to 36 would also be an increase of 7. 36 to 43, increase of 7, and then 43 to 50, also an increase of 7. So then if I look at the y values here, negative 4 to negative 1 would be an increase of 3, negative 1 to 1 would be an increase of 2, and automatically I can say that this is not linear because it doesn't increase by the same number over and over and over again. Because of this 3 and this 2 right here, because all of these 7s were all 7s. So then that means all of the y values should also increase by the same number. It doesn't have to be 7, but it has to be all 3s, all 2s, whatever it's going to be. So next we have finding the slope of a line using the slope formula. So if you remember from the front, the slope formula is m equals y2 minus y1 over x2 minus x1. So the first thing we're going to do is label all of the ordered pairs. So I'm actually going to zoom in here so that I have a little bit more room to write. These are my x and my y values. So hopefully you remember that x comma y is how an ordered pair is always written. Now, this is my first ordered pair. This negative 3 comma 4 is my first ordered pair. So that would be my x1 and my y1 because it's literally the first ordered pair. That's what those ones mean. Then I have 1 comma 12 for my second ordered pair. So that would be my x2 and my y2 because they are literally the second x and y values. So then if I go to plug them in, I have m equals y2 is 12 minus y1 is 4 over x2 is 1 minus x1 is negative 3. Notice that this negative right here is from the formula. This negative is with the negative 3 that was in the ordered pair. So they are separate from each other. So then when I go to do this, I have m equals, go ahead and start simplifying. 12 minus 4 is 8 over 1 minus a negative 3 becomes a big plus sign. So then this is 1 plus 3, which would be 4. And then we end up with m equals 8 divided by 4 is 2. That is as simplified as that gets. Now you could also write this as m equals 2 over 1. That is the exact same thing. You can have the 1 or you don't have to have the 1 if you don't want to. So again, on number 7, I'm going to label my x1, y1, x2, and y2. And then I'm going to start plugging everything in. So m equals y2 is 7 minus y1 is 3 over x2 is negative 4 minus x1 is 6. So then if I start simplifying, m equals 7 minus 3 is 4 over negative 4 minus 6 gives me a negative 10. I can divide the top and the bottom by 2 to give me m equals 4 divided by 2 is 2, and negative 10 divided by 2 would be a negative 5. Moving on over here to 8 and 9. I don't really have much room up above number 8, so I'm going to go ahead and just label my x1, y1, x2, and y2 down below it. And then I have m equals y2 is negative 5 minus y1 is negative 5, and then over 4 minus a negative 2. Then when I go to simplify this, I have m equals negative 5 really plus 5 gives me 0 over 4 minus a negative 2 is really 4 plus 2, which would give me 6. And then something I need you to understand, your calculator will always help guide you in the right direction. So 0 divided by 6. If you type that into your calculator would literally spit out a 0. So that is how you would simplify 0 divided by 6. Remember, 0 divided by anything is always 0. Just something to talk about really quick. M equals 0 would actually be the slope of a horizontal line, so a line that goes like this. That would have the slope of 0. And then going over to number 9 here, again, labeling x1, y1, x2, y2, and then if I plug everything in, we have m equals negative 2 minus 4 over negative 3 minus a negative 3. So then if I simplify this, m equals negative 2 minus 4 would give us a negative 6 over that. Those double negatives there become a positive, so negative 3 plus 3 gives us 0. And then again, if you actually type that into your calculator, negative 6 divided by 0, your calculator would say error. Now, our slope is not error because that wouldn't make any sense. Our slope, if you remember from years past, is actually undefined. That would actually be the slope of a vertical line. Just another little fact. We'll talk more about that in 2.3. I'm sorry, in 4.3. Sorry, I don't know what I was thinking. Wrong chapter. Now, something else that I want to make note of really quick too. Something else I like to say to my kids is that it is okay to have 0 on top. So just okay being a word, O going on top, K on the bottom. It's okay to have 0 on top. And then I always tell my kids that no, you cannot have 0 on the bottom. So again, the N would go on top, O would go on the bottom. And that would be another way that you would know that it's undefined. Again, your calculator is your best bet. It will always tell you what the answer is. So it will either tell you that it's 0 or that it's an error. And if it's an error, it would be undefined. So with that being said, let's go ahead down here and look at 10 and 11. So we need to find the value of r so that the line passes through each pair of points that has the given slope. So very similar to up above, we still need to use the formula m equals y2 minus y1 over x2 minus x1. So if you notice right here, I'm going to go ahead and still label my points like normal. y1, x2, and y2. But you'll notice that they actually gave you the slope in this case. So I'm just going to plug everything in that I know. I know m is 2. So I'm actually going to make it 2 over 1, and you'll see why in just a moment. And then equals y2 is 9 minus y1 is 3 over x2 is 5 minus x1 is r. So we're just going to treat it like it's a number right now. And if you remember, this looks familiar from chapter 2 because this is a proportion. Remember, we always solve proportions by cross multiplying. Now, the first thing I'm going to do, though, is simplify 9 minus 3. So I have 2 over 1 equals 6 over 5 minus r. Then we cross multiply. So I'm going to circle the 2 and the 5 minus r and put parentheses around them because there are two terms there. And then equals 1 times 6 gives me 6. Then I solve this by distributing. So 2 times 5 is 10. 2 times negative v would be negative 2v. Sorry, v. I meant an r. I knew I wrote that bad the first time around. And r equals 6. My apologies. Then we would subtract 10 from both sides. And we have negative 2r equals negative 4. Divide both sides by negative 2. And r is equal to positive 2. Now, way you can check yourself would be by plugging 2 back in right here. So we know, actually you can plug it in right here. We'll go with this one. So 6 is on top. If you have 5 minus 2, that would give you 6 over 3. And then 6 over 3 simplifies to 2 over 1. Something else I actually also want to bring to your attention. Some people have really good mental math skills and can actually look and say from 2 to 6 we multiplied by 3. So then I know that whatever I do to the top, I have to also do to the bottom to make sure it's equivalent. So then 1 times 3 would give you a 3. So you need 5 minus r to equal 3. So then you could think in your head, 5 minus what would give you 3? Then right then and there, you could know that the answer is 2 without ever having to solve below that like we just did. So I'll talk you through that same thought process on number 11. So if your mental math skills are that strong and you can do it like that, great. If you need to actually cross multiply and solve, that's also totally fine as well. So looking at number 11 here, again, I'm going to plug things in. So I know that m is 3 over 4. And notice I'm not putting it over 1 because there's already a fraction here. So I definitely don't need to do that. And then I would have r minus 5 if you label your points here. 4 minus a negative 4 because this would be x1, y1, x2, and y2. And then, again, that mental math piece that I was talking about, the first thing we need to do is go ahead and simplify that. So we have 3 over 4 equals r minus 5 over 4 minus a negative 4 is really 4 plus 4, so that would be 8. So then what I was saying earlier was you know that you have to multiply 4 by 2 to get to 8. So then we know that we need to multiply 3 by 2 as well to get to 6. So then you need to think r minus 5. What number does r need to be in order to give you 6 on top? R would actually need to be 11 because 11 minus 5 would give you 6. So right off the bat, you could go ahead and say that r equals 11 and you could be done with it. Okay, but again, for a lot of people, their mental math isn't strong enough to do that, which is totally fine. Some people would rather solve it and get the answer algebraically by showing all of the work, and that's totally fine. So we have 4 times r minus 5 equals. So again, if that pink part did not make any sense to you, that's totally fine. Pretend it's not there, and we're going to continue solving just like we did on number 10. So then 3 times 8 would give me 24 here. And then again, we distribute. So 4r minus 20 equals 24. Add 20 to both sides. And we have 4r equals 44. Divide both sides by 4, and r gives us 11, like we said it was supposed to when we did our mental math. So again, if the mental math works for you, great, you can do that on your homework. If the mental math doesn't click for you and you want to show your work for everything, that's also perfect too. But that is it for these notes.